Okay. So when we think about a square root function, when we try to graph that, let's just pick some numbers and make a cute little table over here. So if I'm going to pick values for x to take under the square, like to take the square root of, I want to make sure that they're perfect what? Yeah, I want to make sure that they're perfect squares because I don't want to have to try and graph a bunch of decimals. I mean, that's really ridiculous. So let's see, I can use 0. The square root of 0 is 0. Okay. I can use 1 because the square root of 1 is 1. What's the next perfect square? I can use 4 because the square root of 4 is, I am. Are you guys frozen? Sorry. Yeah. So I can do the square root of 4 is 2. And then, yeah, 9 is, what'd you say? 3. Yeah, I'm just going to stop with that because my graph doesn't go all the way up to 16. But look, so when x is 0, y is 0. Let's plot that point. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. Well, much like x squared, the square root of x is the parent function of the square root function, right? So now let's try to do the cube root function. And again, probably if we're going to use the cube root function, we should only pick numbers that are perfect cubes, right? Perfect cubes. So let's think of some perfect cubes. Let's see. Well, 0 times 0. Okay. What's the cube root of 1? 1. Let's see. The next number, if I want to think of the next number, just what's the number after 1? 2. 2 times 2 times 2, or 2 cubed is 8. So the cube root of 8 is 2. 3 times 3 times 3 is 27. So the cube root of 27 is 3. We're doing the cube root, right? Quali, does that make sense? Okay, so Quali. If I think of the cube root of 8, I need 3 factors that are exactly the same to pull one out, right? So the cube root of 8 is 2. If I think of the cube root of 27, that's the cube root of, well, that came from taking 3 times 3 times 3. So the cube root of 27, I need all 3 factors have to be the same to take one out. Do you remember me doing that with you? Okay. So does that make sense now? Okay. And are typically are your graphs big enough to have an input of 27 for x? No. TJ, pick your head up. I'm not going to ask you again. Heads up. Mylena, head up, or you guys can go to the standing table. Okay. So let's graph this. When x is 0, y is 0. When x is 1, y is 1. And when x is 8, y is 2. And that's really all that we can fit on this. But I think that I can take the the cube root of negative numbers. Like, what about -1 and -8? What's the cube root of -1? -1 was made by taking -1 times -1 times -1, right? What's the cube root of -8? -2. So that also means when I think about my negative, I have when x is -1, y is -1. And when x is -8, y is -2. So my graph also goes this way. Okay. So the cube root of x, this is the parent of the cube root function. So just like when we did square root functions or x squared functions, there's going to be a pattern. So let's take a look at the patterns. So I'm going to start with the square root function. So when you look at the pattern for the square root function, if you were to start at the origin, because That's where this started, right? We let x equal 0. Let's see. When I look at my pattern, if I move to the right 1 unit from the origin, how much do I move up? Look at the pattern, just like when we did parabolas. If I move to the right 1 unit from the origin, how much do I move up? What? Guys, listen. If I move 1 unit to the right, how much do I move up? 1. So 1 unit, 1 unit to the right makes me move up 1 unit. If I move 1, 2, 3, 4 units to the right, I move up 2. 4 units to the right, I move up 2. Probably if I move 9 units to the right, I went up how much? 3. Okay, are you guys following the whole pattern? All right, so what is the domain values? What are the values of x? Well, what do you know about the square root? We can never take the square root of a what? So that means that x has to be greater than or equal to, x has to be greater than or equal to 0. Okay. Well, what do we know about the range in this case? What are all my y values? They are also what? They're all positive. Is that what you said, Quali? Yeah, that's the same thing. Y has to be greater than or equal to 0. Now let's look at the pattern on the cubic function. Let's look at the pattern for the cubic function, the cube root. So for the cube root, when I went to the right 1, I went up 1. When I went to the right 8, I went up 2. And very unlikely that you could move to the right 27, but if you were able to move to the right 27, you would move up 3. But remember, this has a negative component. I also can go to the left 1, and that would make me move down 1, because it's negative, right? Or to the left 8 and move down 2. Or I could move to the left 27. Highly unlikely that you have a graph that's big, but if you did, and that would make you move down 3. Does that make sense when I talk about the pattern? Because I've just got the pattern from the parent function. I just looked at this parent function right here and said, when I moved over 1, I went up 1. When I moved over 8, I went up 2. Okay? So let's talk about the domain. What are all the possible x values? What are all the possible x values? Am I using all positive and all negative numbers? I mean, this is all positive numbers. This is all negative numbers. Am I not using all of them? I am. So that's all real numbers. So the domain, all real numbers. Or we, oh my gosh. Or we write it as negative infinity, comma, positive infinity, right? That's how we show all real numbers. What about my range value? Look at your graph again. What are the y values that are going to be touched by your range? Huh? Are they just negatives? And what else? So all real numbers again. All real numbers again. Your range is all real numbers. So negative infinity. Oh, crap. Fantastic. Sorry. Negative infinity, positive infinity. Okay. So we're not doing this whole describe the rate of change. That's not you guys. That's the honors lesson. So go over to the next page. Review of transformations. Review of transformations. Okay. All right. So I want you to think back to when you learned how to graph y equals x. The function, the linear function y equals x crosses the x and y axis where? Crosses at the origin. Yeah, this is the graph. Y equals X. 1, 2, 3, 4. It just goes like this, right? Just crosses at the origin. But when we said Y equals the equation X plus 2, what did I do to my graph? I don't change my slope, but I move it up 2 units, right? Or when I say Y equals X minus 5, I don't change my slope, but I move it down 5 units. So that number that you add or subtract, outside of the function tells you to do what? Move it up or down. So if it's positive, you move up. And if it's negative, you didn't move down. So this is just saying move up 5 units. This next one, it's a cube root, but it's still saying the same thing. Move down 8 units. Now it's a little different when you have an add or a subtract happening inside of the function. It's a little different when you have an add or a subtract happening inside of the function. For example, if I had the quadratic function, just think about the quadratic function, x minus 2, the quantity squared, where is this going to cross the x-axis? What are my roots? Well, this is the same thing as saying x minus 2 times x minus 2. So what are my roots? X equals 2, x equals 2, right? Aren't those my roots? So minus actually moves you to the right. It's counterintuitive. It goes opposite. If you have a minus inside, it actually moves you to the right. So negative would move you, or plus would move you to the left. So inside the function happens in the opposite direction. Inside goes opposite of what it would look like. So this minus 2 actually means move left 2 units. This plus 9, that means move to the right 2 units. Okay? Move to the right 2 units. And then what happens if you have a negative outside of the function? What does that negative outside of the function tell you to do? Charlie, open your eyes and pick your head up. What if I put a negative in front of my x? What would my graph do? It would change the what? Changes the slope, right? So for this case, it reflects. You're going to reflect over the x-axis. So that's how transformations work. So we're just going to look at the parent functions of a square root and a cube root. We're going to look at the parent functions of a square root and a cube root, and we're going to talk about how they move, okay? So the parent function of a square root starts at 0, 0. This starts at 0, 0, right? When I tell it to minus 3, what happens to that? Where does it get moved? Up, down, left, right? It gets moved down 3. So I'm actually going to start at the ordered pair 0, negative 3. Because my whole function gets moved down 3. This function starts at the ordered pair 0, 0, right? That's where we always begin. This says minus 2, and it also has a negative. Also has a negative outside of it. So what's happening to this function? That minus is happening inside. You go right to, good job, Quali. And what else? And you reflect over the x. Okay, what about this last one? It has 2 movements. 2 movements. What's happening inside the function? What's happening outside the function? Yep, left 7, up 9. So just like when we graphed parabolas, we use that pattern of 1 over 1 up 1 over 2 up 4 over 3 up 9. Do you guys remember using that pattern? And we took that letter A that was out in front of our function and we multiplied by the pattern if we had a number out in front. We're going to do the exact same thing. Exact same thing. So this is a square root function. So the first thing I'm going to do is I'm going to write my pattern. Over 1, up 1. Over 4, up 2. Over 9, up 3. That's the first thing I'm going to do is I'm going to write the pattern of a square root function. So tell me what is happening inside of the function. What is happening inside of the function? What are the movements that are taking place? What are the movements that are taking place? Are you with me? Okay. So what's happening? What are the movements that are taking place? What does it say? What's happening inside the function? That -1 tells me to do what? Move to the right 1. So let's write that down. So we're going to go right 1 unit. And we're also going to do what? We're also going to go up 5. This is your A value. Just like when we work with parabolas, we take that and we multiply that by our pattern. So what is -2 times 1? That means instead of going up 1, I'm going to go down 2. What is -2 times 2? So instead of going up 2, I'm going to go down 4. And what is -2 times 3? So I'm going to go down 6. So this original square root function started at the order pair 0, 0. But I'm not starting at 0, 0 anymore. This tells me to move to the right what? 1 unit and up how many? 1, 2, 3, 4, 5. So this is where I begin. This is the first point that I can plot. Because if I use anything less than 1, like if I use 0, what's going to be in the radical? A negative number. Okay? So this is why I have to start here. And then I'm going to follow this pattern that says if I move 1 unit away, I'm going to go down 2. If I move 4 units away from where I started, 1, 2, 3, 4, I'm going to go down 1, 2, 3, 4 units. If I move 9 units away from where I started, which is all the way over to the 10, I have to go down 6 units. So this is how we use the pattern to graph a square root function. So every single time we start at the origin. So these numbers out here, these are just changing the what? What are they changing? They're changing the starting point, right? These kind of give us a new starting point. When we change those, they give us a new start point. So again, I have a square root function. So every single time, the first thing I do is I write my pattern. 1 to the right, up 1. 4 to the right, up 2. 9 to the right, up 3. So that's just came from the square root of 1, the square root of 4, the square root of 9. You guys get that whole pattern thing, right? Okay, so now I'm going to look at my function. Is it getting moved to the right or to the left? It's getting moved down. Down 8. So instead of starting at 0, 0, I'm now starting at what? Starting at 0, -8. This is now my starting point right here. That's where this graph is going to start. Let's look at what happens to the A value. What does the A value do to our function? Well, that means that I have to take all of these numbers and multiply them by 1/2. So instead of moving up 1, I'm going to move up how much? 1/2. Instead of moving up 2, I'm going to move up how much? 1. And instead of moving up 3, I'm going to move up how much? 3/2 or 1.5. So let's graph this. So I'm starting at -8, and when I go 1 unit away from where I started, I only move up a half of a unit. When I move 1, 2, 3, 4 units away from where I started, I move up 1. And when I go 1, 2, 3, 4, 5, 6, 7, 8, 9 units away from where I started, I go up 1.5. This graph is going to look like this. So we're going to look at both graphs, and we're going to talk about the domain and the range for each of them. The domain and the range. Domain is x values, range is y values. So let's look at the first one. We graphed the square root function, -2 times the square root of x minus 1 plus 5. What is the domain of that? What's the smallest x value that you see? What's the smallest x value? Say it. 1. Yeah. So that means that x has to be greater than or equal to 1. If it's anything less than that, it's going to give me a negative number in the radical. What about the range? Tell me about the range. What's the highest or the lowest it goes? What's the highest or the lowest that my graph is going to go? The highest point is what? The highest point is what? What's this point right here? What's the highest y value? 5. That means y is less than or equal to 5. It's just like a maximum on a vertex. Like when we think about the vertex of a parabola, it's the maximum, right? Let's look at the next graph. What is the domain? What's the smallest x value that we used? What's x right there at that yellow dot? 0. X is greater than or equal to 0. Remember that your x values run vertically. I know it doesn't sound like you're so used to the x-axis being a horizontal, but the values run vertically, right? Maybe that'll help you think about it. Your x values run vertically. Your y values run horizontally. So what's the smallest y value? Because this is getting bigger. What's the smallest y value that we use? Yeah, so y has to be greater than or equal to -8. Y is greater than or equal to -8. Okay, I think our next two examples are cube roots. So before I start that first one, before I talk about the movement, I'm going to write down the what? Yeah, the pattern for a cube root. If I move 1 to the right, I move up 1. Yep. When I move 8 units to the right, I move up 2. And if my graph doesn't go to 27, so I'm not even going to write it down. But remember, with the cube root, you also have negatives in play. If I go 1 unit to the left, I go down 1 unit. And if I go 8 units to the left, I go down 2. So tell me what's happening with my function. What's my new starting point going to be, or what's the movement taking place? Yeah, I'm going to go left 5 units. So instead of having my start point be the origin, my starting point is going to be -5, 0. Is there any number outside of the function, like an a value, for me to change how I multiply stuff? Yes or no? No. So this just means from the starting point, if you go 1 unit to the right, you go 1 unit up. From the starting point, if you go 8 units to the right, you go up 2. Or from the starting point, if you go 1 unit to the left, you go 1 unit down. Or if you were to go 8 units to the left, which is going to take you to -12, you're going to go down. It's going to take you to -13. About right here, you're going to go down 2. So your graph looks like this. Ooh, quali. I got to stop that. What is the sign in front of that? What does this say? Which means it's counterintuitive, right? What did I say? What does that tell you to do? Go to the right. That's all right. So over 1, up 1, over 8, up 2. We just kind of graphed it butthole backwards, but that's okay. 5 minus 8 is -3. There we go. That's okay. I should have totally paid attention to that, and I wasn't. So this next one, I don't know if it helps your guys' brain to write it as a cube root, because I think some of you guys need to see that. Notice that there's a negative out in front of that. Not at the, like, it's not on the 3, but there's a negative in front of the radical. Do you guys see that in front of that parenthesis? So let's start with our pattern. So if I go 1 to the right, I go up 1. If I go 8 to the right, I go up 2. But I also can go 1 to the left and down 1, and 8 to the left and down 2. What's telling me is taking place inside of the function? Yeah, this one is a left 3. We're going to go left 3. And then what's that negative like? That negative is the same thing as doing what? Multiplying by. That negative out front is the same thing as multiplying by what? By -1, right? So we're going to multiply each one of these by a negative. So let's see. Instead of going up 1, I'm going to go down 1. And instead of going up 2, I'm going to go, and it's on the left side. When I go to the left 1, I'm going to go up 1. And when I go to the left 8, I'm going to go up 2. So instead of beginning at 0, 0, I'm going to begin at -3, 0. And when I go to the right 1, I'm going to go down 1. And when I go to the right 8, I'm going to go down 2. And on the negative side, when I go to the left 1, I'm going to go up 1. And when I go to the left 8, I'm going to go up 2. Why does that do that? That really makes me angry. Okay. Let's talk about our domain and our range. I'm going to shrink it up so you can see that I'm writing the domain and the range. And I don't think I put this on the filled in notes. You might have to write this down at the bottom for the domain and the range. I don't think I wrote this part. So let's see. My domain. What is the domain? What are all the x values that I'm using? All of them. So domain is all real numbers, and you can write it set notation, -infinity, comma, +infinity. What is my range? Yeah, all real numbers. -infinity, +infinity. And that's going to be the same thing for both of these. Both functions are cubic functions. All right. For our next two examples, it asks us to write the equation of the graph. So let's just first decide, what kind of function is this? Is this a square root function or a cube root function? Number 6, is it a square root function or a cube root function? I'll say it again. Is this a square root or a cube root? Does it have any negative y values? So that means it's a square root function. So this is y equals the square root of something. Well, let's think about the square root pattern. If I go 1 to the right, I go up 1. And if I go 4 to the right, 1, 2, 3, 4, I go up 2. And if I go 9 to the right, I go up 3. So this is following the pattern. So it's the square root of x for sure. There's no multiplier on the outside, right? But what am I doing to that value? Am I moving it up, or am I moving it down, or am I moving it to the left or to the right? because it didn't start at 0, 0. Where did it start? So that means I moved it to the left 6 units. What operation tells me to move to the left? When you have a plus on the inside. So that's this function. Y equals the square root of x plus 6. What is the domain? Well, it's all x values that are greater than or equal to negative 6. What is the range? Yeah, y is greater than or equal to 0. Okay, let's look at the next one. The next one, what kind of function is this? Look at the graph. Is it a square root or a cube root? So y equals the cube root of something. So the first thing I'm going to do is I'm going to use my pattern. If I go over 1, I go up 1. If I go over 1, 2, 3, 4, 5, 6, 7, 8, I go up 2. So that just tells me that there's no multiplier, meaning there's no value out front. There's no a value. So x, now what? I'm not starting at 0, 0. It looks like I shifted to the right, but I also shifted up. So how do I show first off that I shifted my starting point to the right 2 units? -2. How do I show that I move up the y-axis? Plus how much? 1, 2, 3, 4, 5. This is my new starting point, right? You see this is where I'm starting? Okay. So let's talk about the domain. What do we know for the domain? Yeah, all real numbers, negative infinity, positive infinity. What do we know about the range? All real numbers, negative infinity, positive infinity. Okay, flip it over. Flip it over. We're almost done. So let's consider the domain of a square root function, and we're trying to figure out values that we can't have, right? Well, we already did this. We actually did this yesterday. Remember when you have any kind of function, you just take the value and you set it equal to 0, right? So for a square root, we can't have a negative. So that means that x minus 4 has to be greater than or equal to 0. Well, add 4 to both sides. That means x has to be greater than or equal to positive 4. We know that this value right here has to be greater than or equal to 0, and we just solved it. We just said that x has to be greater than or equal to 4. We've already been doing that. Like I said, we did that yesterday. So let's look at each one of these functions and figure out the domain. So that means that 2x plus 5 has to be greater than or equal to 0. If you identify as a man, you're solving that one. Go. Let's go. The next one, 2/3 x minus 8 has to be greater than or equal to 0. If you identify as a female, solve that one. Ready, go. I'm freezing the screen. But my pen's not working. So, Aiden, do you not identify as anything? What's going on? You're just neutral? I love that. Yeah, just don't even, just do your math. Just, yeah, turn around and do your math problem. All right. So when I set the first one equal to 0, here's what I got. I subtracted 5 from both sides. I set it greater than or equal to 0, right? Subtracted 5 from both sides, and then I divided by 2. So I know that x has to be greater than or equal to negative 5/2. How do we write that? Do you guys remember how to write that in set notation? Negative 5/2, comma, infinity, right? So that's how we say that. When I did number 9, I added 8 to both sides, and then I multiplied both sides by the reciprocal, multiply both sides by 3/2, and I found out that x is greater than or equal to 12. And if I wanted to write it as set notation, I'm going to include 12 and go all the way up to positive infinity. Okay. So we are going to state the domain and the range of the radical functions using interval notation. Interval notation, which is what I just wrote up here, because I wanted to make sure you guys remember that. Go away. So let's look at this. Domain. So this is a square root function. What do we know about square root functions? Their domain is what? This is not, it doesn't have any shifting going on. So this begins where? Where does this begin? At 0. So x is greater than or equal to 0. So that looks like this. 0, comma, infinity, parenthesis. Well, what about your range? Is anything happening to your range? That looks horrible. Is anything happening to your range value? Is it getting moved up or down? No. So that means that y is also greater than or equal to 0. Oh, I'm going to throw the pen. Yeah, I just need new batteries. So that also looks like this in set notation. Okay. This is a cube root function. What do we know about all cube root functions? Their domain and ranges are what? Say it. Cube root functions, their domain and ranges are all real numbers. Negative infinity, positive infinity. Negative infinity, positive infinity. Okay. This right here tells me that I moved how many units to the right? 7. So instead of starting at 0, 0, I start at 7, 0. That means x has to be greater than or equal to 7. Bracket 7, positive infinity. So instead of this function going like this negative out front tells me that it's going like what? It gets reflected. So instead of the y values being greater than 0, they are going to be less than or equal to 0. So this looks like negative infinity, comma, 0. 0 is the largest part of that. 0 is the largest part of it. We don't write it as 0, negative infinity. You have to start with the smallest number first. Okay. This tells me that I move 2 units to the left and down 3. So instead of starting at 0, 0, I am at -2, -3. So that means that x has to be greater than or equal to -2. So close bracket, -2, comma, positive infinity. And my y value has to be greater than or equal to -3. -3, comma, positive infinity. I think this is our last one, yes? Okay. So this tells me that I'm going to move to the right 1 and up 6. So that's my new starting point, 1, comma, 6. X has to be greater than or equal to 1. So bracket 1, comma, positive infinity. And y, what happens out front? Is this graph going like this or is it going like this? What does this negative do? It reflects it, right? So instead of y being greater than 6, y is got to be less than or equal to 6. So negative infinity, comma, 6.